Hey, this is Jeanmarc from MilliBox, and this is part 3 of our series of 3 parts where we discussed about the BFX from Copper Mountain and we discussed about the M2 form factor from Virginia Diodes frequency extenders. But now we want to talk about FST. FST stands for Fast Synchronized Trigger, and that's a new feature that we're introducing for our GIM04 and GIM05 3D antenna positioners. And it is effectively a direct link between our azimuth actuator to the VNA trigger input. And we use that trigger input to make acquisition. The azimuth actuators that we use for our positioners like GIM04 and GIM05 is has a 20-bit absolute position encoder built in. And we use that absolute encoder to trigger, to send a trigger signal to the VNA at specific angle. You know, for example, like 2 degree, 1 degree occurrence. And then this train of triggers is gonna drive the VNA to make capture after capture on the fly. Now, on the fly, that's tremendous benefit, as you can see here, because instead of doing start, stop, making a capture, start, stop, making a capture, start, stop, making a capture, now we are doing a full motion in azimuth, and we are dividing the move into angular resolution, where we do capture, 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 right? And that makes it much faster, up to like 10x faster, and nearly like real time. As you can see here, we're doing a -90 to +90. So it's doing some kind of a zigzag pattern like this, and it's capturing on the fly, on the go, and driving just by the automatic trigger, instead of doing software synchronization. So that's the novelty for FST, Fast Synchronized Trigger. And available for, like I mentioned, GIM04 and GIM05. They can be equipped with it. That's the F option when you order. And also, we're offering that feature for retrofitting existing. So for you guys, if you have a GIM04 or if you have GIM05s and you want them retrofitted with FST, we offer that. And then that will be a retrofit, an upgrade. You have to send back your unit, and we'll retrofit it and send it back to you with the FST integrated. So that will divide your capture time a lot, depending on the resolution, of course. So we have 2 types of capture. One capture is for one frequency, and then you do the sweep directly for that particular frequency, and you do the full acquisition in 3D. Or you can even, for the VNAs that do support this feature, and some manufacturers have this feature readily available, where you can do the entire trace on the fly, which is like super powerful. In few seconds, you're gonna get like 20 or 30 radiation pattern. Here in our example, I think we do like 71 radiation pattern in one shot in seconds, like you can see here. So we're gonna show that. Let me show it to you in what it looks like when you control the machines. The MilliBox software on the left, the VNA on the right, and the camera inside the chamber also on the lower right. So we're going to do a 3D plot. Then we'll do a surface plot and a start angle. It's going to be minus, let's do -40 to +40 in both azimuth and elevation. They will do a 2 degree resolution. We could do a lot less, but and then a tag, and the frequency, let's do 110, and let's go. And then here we use the external trigger, yes, and then use the sweep external trigger. We'll say no, and then let's see how it goes. issue. So now we see the progress, but it's going like super fast. So now it's doing for just one frequency, the frequency that I selected, which is 110. So we're not capturing the entire trace, we're just capturing the 110 point. In the CSV file where we have the coordinate system, and then we have the power level that we measure from the VNA. So you see how fast it goes. So you don't even see the number of triggers. I mean, they're in like milliseconds. We trigger and do an acquisition, and then we plot it on the VNA side, and also we plot it on the MilliBox software side. So that's how fast it goes. And we see we're already past halfway. So some a plot like this would take like probably 15-20 minutes with the stop and go method. But here with the FST in place, it's on the fly, and then that's going to be what it says, estimated in 3 minutes, I think. Yeah, 4 minutes. So significant reduction. And also we can notice that the motion is really smooth because we don't have those, jerkiness instead of like stop and go, which puts a lot of stress on the system. So here it's just like sweeping, in zigzag mode, one way, and then building the 3D radiation pattern. So we're already done, right? See, that's amazing. So now we render it like this. Let me bring it back to your screen, and then that's what we got, in 3D. So that's what we just capture, like literally in 4 minutes. Here we are trying something else. So we're still doing a 3D plot, and then we'll use this time the heat map just to change a little bit, and we still do -40, +40 in azimuth and elevation with a 2-degree resolution, and so we'll do really similar condition. The plot will still do 110, and we use the hardware trigger, and we use the sweep. The sweep trigger. So this time we'll do the entire capture, the entire trace. So as you can see, it's going like super fast. Let me move that a little bit out of the way. So you see we have a different experience on the screen. The trace is no longer updating, that's fine. And then we're counting the trigger on this interface. So that particular mode where you can capture the entire sweep on the fly with triggers, that's really advanced feature, and that's available on the Copper Mountain VNA, the BFX. That's not available on every VNA from every manufacturer. You need to check with them. But we know that Copper Mountain technologies do support this, and then here we are using the BFX 2, their new model. So here we're progressing like super fast. We are taking 71 points from 75 gigahertz to 110 gigahertz. So 71 radiation pattern in one shot in about 2 minutes. For that many points, -40 degrees, +40 degrees in both elevation and azimuth at 2-degree resolution. So that's like a huge amount of data that we're just capturing on the fly. And you see how smooth the motion is. There's no stress on the DUT or on the overall positioner. It's just moving left and right with the zigzag pattern and capturing as fast as possible. So that shows the full power of
using FST, the Fast Synchronized Trigger, that we just implemented for GIM04 and GIM05. So that will save you a lot of time doing your high resolution captures. So here we're done. So now we can close it and we'll see the rendering in, oops, push it a little bit here. You see the rendering in 3D, which is exactly the same, same way we had it with just 1 point. So that's a 110. But now look, I go there and I can show this, the file, the CSV file where we have these data collected. We can render any one of those 71 points, frequencies, radiation pattern. So let's do that. Let's try like the starting point, which is 75 gigahertz, and then boom, that's it. I have the 75 already captured it, and then I want another one. I want let's say 95 gigahertz. I got it. We have it right away. So all 7, I could repeat that 71 times, and it will be the same story. We have all 71 radiation pattern in the shot at 2 degree resolution, and we did that in about 2 minutes. So that shows you the advantage of using FST when you can. So if you want to get it for your system, just contact us, and then we'll talk about it.
Right, so you've seen how powerful it is. I mean, FST is awesome. I love it. I think everybody should get one. But if you need, I mean, if you have this kind of specificity, of course, you don't use FST if you want to do like radar measurement and things like that, or spectrum analyzer. We don't know yet if we can adjust FST. But for typical setup with the VNA, yes, for sure, FST is your friend. It's going to save you a lot of nights. Okay, so if you want to know more about it, don't hesitate to contact us, or you can visit our website, like you see here, and we can see your specific needs and how our solution will benefit your setup. So this concludes our 3-part series when we introduce you to different aspects of this setup. This setup is extremely powerful. It's completely modular in size, in types of positioner, types of measurement you can do, and in frequency. Now with those extenders that cover like a range from maybe 18 gigahertz to 330 gigahertz, you can have different bands and different requirements with the same base. So you have the base will evolve with your needs along the way. So that's terrific that way, and it's super affordable. I mean, that's the best value you can find anywhere on the market. So we will show this setup at IMS 2026 in Boston. So if you're here, if you're there, don't hesitate to come and say hi, and then we'll show you in more detail face-to-face these demos and these products. So we'll be booth 13075 IMS in Boston. So we'll be glad to see you there. Talk to you later.